Number 9, draw a Lewis structure for each of the following polyatomic ions, and then use Vespers theory to determine the geometry of each. So we're doing essentially the exact same thing as we did in number 8, but here we're doing it with ions. And so you see the only thing we're doing differently is we have to surround the entire Lewis structure with brackets and then identify that overall charge. Well, you don't even have to know what the overall charge is because I give it to you here in the problem. You just have to include that around the outside to indicate the overall formal charge. So, in O3, nitrate. Okay, we have 3 oxygens. One of them is going to need to be double bonded up. Okay, one of them is going to need to be double bonded up. This is going to be, goodness gracious, I believe I made a mistake right there. I believe that this should not be present. This lone pair should not be present. Hey, my bad. So ignore this lone pair right there. Ignore it. Okay, I don't want you to pay attention to those 2 right there. As a result, these 3 bonds, these 3 electron domains are going to spread out evenly to result in trigonal planar geometry. Now let's go over here. We have NH4. So we have our central nitrogen surrounded by 4 hydrogens. Right? There are no lone pairs. Right? That's what this proton was able to bond with. The lone pair that nitrogen brings to the table attracted this proton. And so since we haven't gained any more electrons, but we gained this 1 proton, there's an overall +1 charge. Tetrahedral shape. Let's go sulfate, our central sulfur. We have 4 oxygens around it. We got our 4 bonds to singly bond each of the oxygens. There is an overall 2- charge, but because we have 4 single bonds to the exact same type of element, we have a tetrahedral shape. Then lastly, ClO2 with a -1 charge. Here's my -1 charge, right? Brackets, -1 charge. I'm going to have a central chlorine. And then, let's see, central chlorine, oxygen, chlorine. Chlorine is actually less electronegative in this case, which isn't the case often, but here it is, so it's central. And so I have 2 bonds, 1 to each oxygen, right? And then I have 2 more lone pairs. Those lone pairs are driving the bond angle down, so we have a bent geometry with a -1 overall charge.